our rules of this meeting is if you want to say something, turn off your microphone, okay? Okay, so we also need this ready for can't record microphone in use. Oh, okay, that's okay. We're not recording this way. We're recording on the other one. Okay, so let's take a look. So what we're doing today is our notes are on. Let me change colors for you guys. Okay, so this is on section 11.2 and 11.3. Okay, so it's a little more for vectors. Okay, so this is more vectors, more 3D vectors. Okay. Wow, I write way messy with my tablet pen. I'm gonna write with my phone pen. It's way better. Okay, so one question. So see if you guys know how to do this one. So it gives you a vector. Okay, so we'll just start with examples. Right now, there's nothing that's really new. We'll call this one example 1. So the first vector is 2, negative 9, 3, and it says the initial point. So initial point, and it gives it 2 as a point. Actually, it's my tablet screen here that's a problem. Not a problem, but it's just a little too slick. So I'm not writing too neat here. Okay, so we have a vector and initial point, and it says find the terminal point. Okay, so work that out on your paper. So find the terminal point. Okay, so think of how vectors work. So I have my initial point right here. I'm just going to call it IP for initial point. That's not like an official abbreviation. And then I want to find my terminal point. And then vector V supposedly is going to be what connects them. Okay, so if this point is 3, 5, 7, and the vector is 2, negative 9, 3, tell me what you think the terminal point would be. Tell what you think the terminal point would be. Now that's a point, not a vector. So let me make sure that I have this as a parenthesis. Anyone have an idea? You can type it in. You could say it. What do you think? Any guesses? I do. That's exactly what I do, Daniel. Because basically this 2 is like change in X. So I'm at 3 and I have to change X by 2. So now I'm at 5. And I'm at 5 and it says change it by subtracting 9. So now I'm at negative 4. And then I was at 7 and I need to change it by 3. And so that'll be 10. And what do you think? Does it look like that would be the vector? How do you get from 3 to 5? 2. How do you get from 5 to negative 4? Negative 9. How do I get from 7 to 10? 3. So that's your terminal point. I kind of like the drawing than just having an answer. But it would be okay if you just had an answer on this one. You wrote the problem down and you wrote the answer, and then that's it. Okay, this one's kind of a more challenging one. Okay, so at this point, it's not like there's anything specifically new in that one. It's just some vocabulary. But I like this one. This is for some of the questions in the problem. So it says vector V. So vector V, and you want to put a little vector on top of it. In the book, they bold them. So vector V lies in, and then they tell you a plane. So I'll do the plane that they're, well, we'll do XZ plane. So it lies in the XZ plane, and it tells you the magnitude. Okay, so this one, the magnitude is 12. And it says it makes an angle of, we'll do 30 degrees with the positive Z axis. And they want to know what the answer is. Find the component form of V. Okay. So you kind of have to draw it a little bit. Now it lies in the XZ plane. Okay, so this plane right here is normally not the XZ plane. Okay, so normally that's not the XZ plane, right? Normally this is the YZ plane, and then X goes like this. But I don't think that's going to help me solve this problem. Okay, so I don't think that's gonna help me solve the problem. So I think I'm gonna redraw it just so I can see it. And here's the X and here's the Z, just so I can see it. Okay, so this is the real way to graph. Okay, but this is to assist my problem solving. So fun, like I'm actually talking to students instead of me just talking to random, like my puppies and thinking they're students. Okay, so it says lies in the XZ plane, okay, with magnitude 12, makes an angle of 30 degrees. Okay, makes an angle of 30 degrees with positive Z-axis. Okay, so the positive Z-axis, that would be this top part right here. So I'll highlight it. This is called the positive Z-axis. Okay, and then I want a 30-degree angle with it. So I guess that would be here. That's not 3D. That's just the 2D version. Or is there another potential angle with the positive 30-degree axis? Isn't there another one? So I'm going to draw that one in another color so you can see it. I think also green. I feel like it could also be where the green is. Okay, so where's the 30 degrees? So the 30 degrees is right here, right? It's kind of not in our normal position. Okay, I'm going to move my letter Z up higher. So my letter Z is up higher. So and now it says the magnitude is 12. So think about where the magnitude would be. So the magnitude is really the hypotenuse of the vector. I'll draw a little vector arrow here so we could tell that they're vectors. Okay, so how can I make it so I can figure out what the sides are? I'm thinking I could use sine, cosine, tangent, but I'm thinking that I could just figure it out using, you guys remember the triangles? Okay, so if you have a 30, 60, 90 triangle, what are the side lengths? See, I'd rather have you guys with, I don't know if you guys then you'd all answer at the same time, but it'd be kind of cool if your microphones were off. You guys only have 23 people. You could actually answer. What do you think? Anyone want to turn their microphone off? On, I mean, so you could see? So you could talk? Oh, I hear somebody. So the 12, is the 12 the A rad 3, or the 2A?
2A.
Cool. And it's anonymous. Well, it's anonymous for me because I can't see who did it, but that's cool. So 2A equals 12. And then A equals 6. Hey, somebody else, where do you put 6? Oops, sorry. Anybody else? Yeah, you guys remember this? So this is 6 rad 3. This would be 6. This is 12. Right? So you could put that back over here on the picture. Across from the 30 is a 6. Across from the 60 is 6 rad 3. And then the hypotenuse is 12. So now, when you write the coordinate here, or the vector, this is supposed to be a vector, right? Not a coordinate. So let me erase it so it doesn't look like a coordinate. But when I write the vector here, what would the x coordinate be? Anyone want to tell me what the x coordinate is? In the chat
6.
or with the vector? 6. Nice. 6. So this is 6. This is so cool. Okay, and then what's the 6 rad 3?
The Z.
The Z. Awesome. Okay, so what's missing?
The Y.
The Y. Okay, so what are we going to do about the Y?
Put a 0.
Put a 0. Why would you put a 0? I agree. You put a 0 because there's no Y coordinate. Now this is not the way Y is supposed to be, right? But I just slanted it up. Like there is some Y coordinate, but it says it's sitting on the plane. So that means Y is 0. Okay, so that means Y is 0, the one that they don't mention. Okay, and then technically, I feel like there's another answer. I don't know if the book will say there's another answer, but I feel like there's another answer because the positive Z-axis, it could be on the left. So is that -6, 0, 6 rad 3? Oops. So probably the book has this answer, but I think they both work. So I would say or. Okay, so that's a throw your math at it problem. Okay, so that's the whole point is math isn't about like you memorizing what we do. It's about throwing your math at it. Okay, so that's a good example of throwing your math at it. And how interesting that there's no test, but this usually is not on the test anyway, that question. That question isn't on that test. This one, maybe example 1, but usually it's written as a different format. Now, how's the connection? Are you guys, am I lagging? Because I'm on my mobile. Yeah, I'm on my mobile hotspot, not my Wi-Fi. Yeah, because my Wi-Fi is too slow in my living room. Okay, cool. Okay, so you guys ready for the next one? So example 3. So example 3, now I believe that was those are the only 2 problems in 11.2. So example 3 is actually when you change to when you change over here to 11.3. Okay, so example 3 is 11.3. Okay, and this one, there's a question that says, so this will be interesting. Hopefully you watch the other video. So find a vector. So far there's nothing new. It's just written in a different way. So find a vector orthogonal to U, and then I'll give you what U is, and V. Okay, so we have 2 vectors, whatever they happen to be. So I'll just put numbers in there. Let's say 2, 1, 6, -3, 5, 12. Okay, and I need to be, oh, the lag, it's a little laggy. Okay, at least it's a little laggy from my tablet to my computer because I'm there twice. So orthogonal. Hey, it's not circling it at the same pace. Interesting. I wonder if that's because my computer. Oh, okay. No, I think I'm on my Wi-Fi for everything. Yeah, I'm on my Wi-Fi for everything. I mean, I'm on my phone. So orthogonal, what does orthogonal remind you of? What's orthogonal mean, but like in English and not in vector math? Anyone want to say in the chat or in the, like, take off your microphone?
Perpendicular.
Perpendicular, okay. That's so cool. Okay, so orthogonal is basically the same as perpendicular. And what's one thing you know about orthogonal? It doesn't answer this question, but what's one thing that you did orthogonal like the day before? And in chapter 6? Anybody? Orthogonal? Dot product is 0. So dot product is supposed to be 0. So I need a vector whose dot product is 0 with both of these. So it's another vector. Okay, so I'm going to call it vector W. So vector W is supposed to be perpendicular to both. So what I want, and I'm writing this over to the side, is I want U dot W to equal 0, and I need V dot W to equal 0. Does anybody remember? Don't flip your notes pages. Does anybody remember from the previous homework what makes you a perpendicular? Anybody know? I wish I was like in person with you guys so I could show you this. But okay, so ready, this little red thing? Okay, that's a pen. Ready? So pick up a pen on your desk. So that's a pen. Okay, pick up another pencil on your desk. Okay, so here's another pencil on your desk. Okay, now these are vectors U and V. And you want a vector coming out of this piece of paper straight up at you. So do you see the shape that this makes? I usually show my students with pens. Okay, so it makes an X. X for cross product. So the cross product is the math object that is orthogonal to both of them. Do you remember when you found the cross product in 11.3 on the previous homework? And then it said check and show that it's orthogonal to both. And it always was. It does prove it, but I don't think you're assigned those questions. But if you want to try to prove it, it's actually later on, probably somewhere. Oh, I don't see it anymore. It used to be in our old book. Oh, that's interesting. So I don't know. Yeah, that's interesting. Maybe it's not there. Yeah, but we used to have a problem where it proved that it really was, but it was really complicated, so no one usually did it. Okay, so remember how to do the cross product, the actual operation of the cross product. So you put IJK at the top, and then if it says UVW, or sorry, that's not. See, this is perfect. Did anybody catch my error? You guys didn't tell me my error. What's that supposed to be? It's supposed to be V. Okay. So remember, you guys, you're here for the learning, but you're also here to help me find my errors, okay? The thing I highlighted is what I just changed. So double check that that's right on your paper. So W, the cross product, is U dot V. Okay, oops. So the cross product, let me write this here. The cross product is perpendicular to both. Okay, so that's 2, 1, 6, negative 3, 5, 12. And then I want to do the cross product. So try to do the cross product. I won't say it so that you can try to do it on your own, and then you can look up and check after. But if I say it, then you're going to hear me. And then I'm going to show you the work that I would show. And I really wouldn't use the highlighters, but they're kind of fun so that you can see what I'm doing. Okay. And then the next one. Oops. You guys, I don't really put this like this green line in person when I'm doing it, but I think it helps me to show you as I'm doing it so you could see what I'm doing. So I'm doing yellow minus blue. Okay, so yellow is 24 because I'm multiplying, minus blue, which is negative 18. And I usually don't change that to a plus yet, because otherwise sometimes I'll make a mistake and I'll think, oh yeah, that was supposed to be a positive, and then I forgot that it was minus a negative. And then this one right here, oops, let me put that back in. So I'm going to erase the yellow and the green. And then that's down minus up. Oops, I got to block out the K's. This is down minus up. Probably you guys are done already because I'm trying to show all this work, but probably you're done. So this is negative 18I minus 42J. And remember, like, put a star here so you remember that's a minus, plus 13K. Okay. Okay, now this answer, you could write it that way, or you can write it in component form. This form is called a standard unit vector. Okay, so this is the answer for W. Okay, now, what was W's job? Right, so W supposedly is the answer, but I always check this one anyway. So even if you guys weren't here, I always check it. Okay, so you're going to check. You're going to do the dot product of this. I don't always write it. I usually look at it with my fingers. Okay, so this dot product is supposed to be 0. So that's what? Negative 36 minus 42 plus 6 times 13, 8, 1, 78. 78, and I'm hoping math prayer for 0, which it is. And then I also am going to try negative 3, 5, and 12. And that dot product with this negative 18, negative 42, 13 is also supposed to be 0. Seems like I'm writing messier today. I think I'm at a bad angle. Minus, what, 210? I don't know what 12 times 13 is. What, 156 maybe? Okay, so if I add the positives, that's 210. 210. So I think I'm good. So this usually I kind of do in my head. You're allowed to write it out, but I usually do it in my head, and it reminds me that dot products have to be 0 to be perpendicular. Okay. And cool. And remember, the reason you're learning the material is you don't want to be missing out on a material that you are expecting to learn this year. Okay, so you do still want to learn it, do the homework. And then the homework is going to be able to be counted because we're going to reassign it afterwards. But then you're going to have homework for your other classes. So it's better to get your math stuff done now if you can. Okay. The main thing is to be safe with your families. So that's the answer. So the answer is W. Okay, and that is a vector that's orthogonal to both. Okay, now let me give you a formula for the next one. That was example 3, right? So let me give you example 4. Okay, so example 4, it's the area of a parallelogram. Okay, and there's a formula. So, well, let me show you the picture first of the parallelogram. Here's the parallelogram. This is vector u, this is vector v. They have to be adjacent vectors that share the same initial point. Okay, they share the same initial point. And the area of the parallelogram is the absolute value of the cross product. It has to do with the cross product being the sign and using actually the law of sines, or you remember the area formula that's like 1/2 the 1/2 the lengths times the sine of the angle in between. Okay, it turns out that this is related to the cross product. Oops. You don't have to know that though, but that's where it comes from. And then there's 2 of them. Okay, and then that one turns out to be this answer right here that I wrote on the right. This is the magnitude of the cross product with the sign. The dot product is related to the cosine and the cross product is related to the sine. It's pretty cool if you ever want to watch a YouTube video and see how it's proved. But I'm going to erase that because that's not really anything that anyone needs to know. Okay, and then you don't even have to know the theta. So erase the theta. Okay, so what does a cross product give you? Anyone know what a cross product gives you? Does a cross product give you a vector or does it give you a number?
Vector.
A vector, okay. Now I appreciate the person who's talking, but some of the rest of you guys could talk too if you wanted. Okay, let's do, we'll do a different one. We'll do a different one just for practice. Okay, so let's have you, but person who's answering, I really appreciate you answering. So keep answering, okay? But if anybody else answers, that's good too, okay? So let's have some vectors. We'll make them all positive, but it doesn't matter. They don't really have to be positive. 4, 10. Okay, so you have 2 vectors. So how do you find the cross product? Right, so how do you find the cross product? So you're going to do the same thing. 1, 2, 3, 3, 4, 10. There's another way to find the cross product with a formula, but it's way more complicated. So this is the normal way that we do at our school. So it's I minus j plus k. And you won't see vectors in AB calculus. You don't see vectors again until BC and HL. Okay. And then for this one, it's downs minus ups, right? So maybe I should write that instead. Let me put downs. Let me write it right here. Down minus up, right? Down minus up, down minus up. Okay, so the down would be 20 minus 12 because I'm crossing out the first. I'm crossing out, not that row. Okay, not that row. Hold on. What was that number? Was that number 3? Okay. Sorry, my new pen has a button on it that's very annoying. Okay, my tablet pen. So that's 20 minus 12. And then I'm going to erase that line. Okay, put the new line in. Erase these 2. And then I'm going to do the same thing, down 10 minus up. Okay, so that's 10 minus 9. And then the last one, you're going to block out the last column. Okay, the last column. And then that would be, let me erase my down minus up. Okay, so you're down 4 minus your up 6. So let's see, 4 minus 6. Okay, and that would be 8i minus 1j minus 2k. Now, does this seem like an area? What do you think? Can that be area? So area equals this. That doesn't seem right. Yeah, area can't be that. So area needs to be, if you kind of want to make a vector into a number and you realize, shoot, I forgot how to do it. Usually it's the magnitude. Okay, so what is, and then personally, I don't really like to find magnitudes with the IJK. because I think that the IJK makes me feel like imaginary numbers, and I feel like I want to square the I, and then it messes you up. So I like to write it in component form. So 64 plus 1 plus 4. Okay. And this is the square root of 69. So that's actually the, and now, remember that other video where it was a triangle? And some of you guys wrote, hey, Miss Nichols, you screwed it up. You were so nice. But anyway, what did I miss? I missed the 1/2, right? So is this a triangle? Is it a triangle? It's not. It's a parallelogram. Okay, go Sabrina. Good job. Okay, you can speak too. Maybe you're the one who's speaking. Okay, but that's awesome. Okay. Welcome, Ziyu Chen. The only thing I wonder is if you guys came in late, I wonder if you're going to be confused. I don't think so. I think this is a lesson that it's okay if you went out of order. So those of you who just came in, it's totally fine. Okay, so if you just came in, just copy notes from our example 5, and then you can go back. Okay. Okay. So what is this problem above? Well, let me give you a different problem. So example 5. So for those of you who just came in, just start on example 5. So example 5 gives you some points. So A is 2, 3, 9. Point B is -2, 4, 7. And C is 0, -2, 3. And it says find the area of the triangle. Now, it is not the 2D version. Do you remember the 2D version? So let's write the 2D version for matrices. So the 2D version for matrices is you do x1, y1, x2, y2, x3, y3. And then do you remember what you fill in the last column? Perfect. So that's the last column, right? So this is area in 3D. Oh, triangle. But what did I forget? My 1/2. You know why I forget my 1/2 sometimes? Because I think, oh, I forgot my absolute value. So I forget that I need the absolute value for area. So since I forget to do the absolute value for area, I add that in. So I forget that I have to add the absolute value and the 1/2. So that tends to be why I forgot. So this is the 2D version. So we'll put this is not 2D. Now this is the 2D formula. Okay, so this is the 2D formula. This is the 2D formula, this is not the 2D formula. Yes, Bill, it's 11, 2, 11, 3. So you would have already done a little bit of 11, 3. But it doesn't hurt to watch anyway. If you haven't done any of 11, 3, or you haven't watched the cross product video, you're just gonna be a little confused by the cross product thing. It's gonna seem like I'm going too fast. But I'll show all the steps in this one. Yes, Bill, it is going to be posted on YouTube. Every video that we do is going to be posted on YouTube. Okay. Okay, so for this one, anybody have an idea of how we're going to find 5 not using the 2D formula? So the 2D formula is completely irrelevant. It's not going to work. Like at all, not even a modification. So you're not going to be able to throw in X, Y, Z, X, Y, Z, X, Y, Z. Actually, that turns out to be volume, but not of points. Anyone have an idea? Want to put their microphone on?
Could you find the vector of AB and the vector of AC and do the cross?
Yes. Okay, stop. Hold on. Good. Give them a hint. Okay, so let's draw the picture. Hold on. So let's go with this. So we're just drawing some random triangle. AB. And what I liked about what you said is she didn't say AB and BC. She said AB and AC. So I agree with that. I'm going to label them U and V, but I probably, in my real problem, I'm going to label them AB and AC. Okay, now somebody different. What formula can I use now?
Cross product.
Cross product, good and good. Cross product. So I'm going to do the cross product. Now I'm going to do the cross product of AB with AC. Now, which formula am I technically using? So I'm going to write the formula out. Anybody? Where did I find the formula? Or where can I find the formula? Example 4. How can you modify that formula for this problem? What should I put in the front? Yes, that's exactly what I should put in the front. Okay, so I should put a 1/2 in the front. So the area is the magnitude and then the 1/2. And you don't need the absolute value of the magnitude because magnitudes are always positive. Now it does have to both be A when you're doing that. It doesn't have to both be A, it could be any letters. Okay, and then, oops, I didn't do this other part of the triangle, but that's basically what it would be. Cool, so then we need to find it. Now, how do you find AB? So AB, you start at A and you're trying to get to B. I don't like to subtract backwards. I think, how do I get there? So I'm at A, I'm trying to get to B. So that'd be -4. And then I'm trying to go from 3 to 4. So that's +1. Trying to go from 9 to 7, that's -2. AC, A all the way to C, that'd be -2. Or this one, 3 to -2 would be -5. And 9 to 3 would be -6. Okay, and then we're going to do the cross product, and then we're going to do the 1/2 and the magnitude. Probably, I'm going to write that formula, but let me just do the cross product over here separately, because I don't want to keep including all that stuff in it. So remember the cross product. Now, if you didn't watch the previous video, then you might not know what this cross product is. So maybe I should definitely show the work so you guys can see what I'm doing. Okay, so usually I don't show one step when I'm at this assignment, but I want to show it because of the notes we're doing. And then we'll remember, supposedly, we're going to remember the 1/2 after. And the absolute value, the magnitude. Okay, so this one is I, and this time I'm going to show the step. It's really times a determinant. Okay, so it's really times a determinant. And the reason why you're watching the videos and practicing the questions is when you see this stuff in college, if you've never seen it before, it's going to be traumatizing, right? So we want to make sure that you see this stuff. Now, you also see it in my HL math class. Okay, so you'll also see it in my HL math class. Okay. So this is what you write in each. And I was showing you in the other one how I really kind of do it in my head. Okay, so I kind of do most of it usually in my head. That one I cross out the reds, so now ignore the greens. And it's -4, -2, -6, -2, -6. Okay, and then for K, you're going to block out, we're going to block out the K column. Okay, and then you see -4, -2, 1, -5. So it's like these guys right here crossed. Oops. It's these guys are still there. And then it's just that big.
Could you please scroll up a little bit?
Is that enough?
Yes, thank you.
Okay. Okay, so then this one would be, let's see. Nice. Okay, so this one would be I, and then how you do a determinant is down minus up. Okay, so that's how you do a determinant of a 2 by 2 vector. So it's -6 minus +10 minus j. And there is a spot to check my work. So usually I go pretty fast through this spot because I do find my errors. Now I have you guys, so if you find an error, it's no problem to tell me ahead of time. But there is a spot where you're going to find your errors in this if you make an error. Okay, so that would be 20 minus -2. Okay, so then this would be -16i minus 20j, and then plus 22k. So now this vector that I just got, how can I tell if I made an error with all those steps, with all those negatives and numbers and multiplying? How can I check it?
Dot product.
Dot product. All right. Okay, so I'm going to check it with the dot product, and the dot product of what? Each of the individual AB or AC vectors. So what I usually do, I'll write it over here, my check. Okay, so what I do, I'll highlight them both. Let me erase my other highlightings. Okay, so let me show you what I do. I look at the yellow, okay, and I look at the blue, and I just do the dot product. On the side, I multiply it in my head. -4 times -16 is 64, plus 1 times -20 is -20. -2 times 22 is 44. -44. Good, that was 0. Okay, and then I change which one I'm looking at. So now instead of looking at the, instead of looking at that yellow, I'm going to look at the bottom yellow, and I'm going to do the same thing. So I'm dot producting the yellow and the blue. So that would be 32 plus 100 minus 132, which is also 0. Okay, because I often used to make a mistake when I was doing the cross products. Okay, so you want to be able to check it in a different way if you can. Okay. Now, we're almost done, right? So I'm going to go back up, kind of put this over here, right? Put this over here. So it's 1/2 the magnitude of the cross product. Now, because I just made up these numbers, of course, they're very big. How do you find the magnitude of a vector? Anyone want to tell me? 26 people. This is so awesome. You guys are so awesome. How fun. How did I check my work? Okay, so how I check my work is I did the dot product. Let me actually write that out. Okay, so let me show you where I got this one. I dot producted -4, 1, -2, which is AB. And I dot producted my -16, -20, 22. So that's how you check if it's orthogonal. So then I multiplied the x's, and that's how I got 64. Let me highlight this for you. So I multiplied these two numbers, and that's how I got the 64. And then I multiplied the 1 and the -20, and that's how I got the -20. And then I multiplied the -2 times the 22, and that's what gave me the -44. And then I needed it to be specifically 0 because it's supposed to be perpendicular. So if you find the cross product, it's supposed to be perpendicular to the original vectors. Okay, the original AB vector and the original AC vector are supposed to be perpendicular to this vector under here. Does that answer your question, Richard? Okay, cool, good. I'm so glad you guys are here because these are, if you don't ask these questions, sometimes I'm pretty good at predicting questions, but not always. So I'm so happy you guys are here. Well, I'm thinking Sunday nights and Monday nights, or like say maybe Monday afternoons, Sunday afternoons. I'm not sure what'll work, but I'm going to try to put like a schedule, like which kind of days do you like, you know, and then I'll make it Sunday, Monday, and then I'll make all 3 videos those 2 days. And then if you want to watch them live, you can, or you can watch them during the week. But I like the idea that at least some people can watch them live, especially because I think I made a mistake in every single video before. Okay. That is nice, because then you guys ask questions, and it feels like class. Okay. Okay. So that, oh, I didn't finish. Okay, so we're back here. So 1/2. How do you find the magnitude?
You square it.
You add it.
Yes.
You square root all of it.
Perfect. That's so cool. Okay, so -16 squared plus -20 squared plus 22 squared. You guys, it's so much better teaching you than seriously teaching my couch and my puppies. You know, they don't understand anything. Okay, so this is 256, 400. I don't know what 22 squared is. 484? 44. So this is 1/2. And why is there 1/2 that I forgot in that other formula for matrices? Why is there 1/2?
It's an area of a triangle.
Area of a triangle. Okay, what if it was a parallelogram? Any idea, you guys? What if it's a parallelogram?
3.
Would you have the half?
Wait. I said
Would you have the half if it was a parallelogram? Oh, that's interesting. So the absolute value would still be there and not the 1/2. Exactly. Okay. And Richard, the absolute value means determinate. I mean, it means determinate if it's a matrix. Okay. So these, I mean, and this is for everybody, but this right here, this one means determinate. My yellow highlighted, but my blue highlighted. Isn't it funny that the absolute value means something different depending on its situation? They're very related though. So that's why they use the same symbol. They're actually called something else in England, because I teach IB. In England, absolute value is not called absolute value. It's called the modulus. And so the determinant is a type of modulus, and so is the magnitude of a vector, as is your normal absolute value. It's like super cool how everything is connected. Okay, I'm trying to reduce this. My number came out way too big, which is annoying. But this is what, 2 radical 285 times 1/2. So that's radical 285. But you don't know if it'll be a calculator or non-calculator question. 285, can I divide again? 5, 57. 57's what? 3 times 19 times 5 times 4. Okay. So 285. Okay, and you guys, if you see my errors, you got to make sure you point them out to me, okay? Okay. So that's it for that. Okay, that's it for that. Now that used to be on the test. Summer school, we used to put this chapter test with the matrix chapter test. And so I would have to tell the students, like, remember, don't use the 2D one on the 3D. On the 3D one, you have to use the cross product. But on the 2D one, you just use that determinant, absolute value of the determinant. And these are things that you can look up. So if you don't own the formulas, in your brain for your future, you look them up. What we need you to know how to do is how to do a cross product, and to know that cross products are perpendicular to each of them. So you don't have to memorize formulas. You'll be able to look them up, right? I mean, supposedly. So if you didn't remember a formula 2 years later, it doesn't matter, but you want to at least have done some practice cross products so that the cross product process doesn't seem overwhelming the next time you see it in a math class and they're like, oh yeah, remember the cross product? You're like, oh shoot, I didn't do any of that homework during the closure. So you want to make sure that you're still doing it if you can. Above all, we need your families and you to be safe. Okay, so let's go to our last 2 examples. And I've never known why this works, but it's like the coolest thing. This is the volume. Oops, volume. How come my pen's not working? How weird, my tablet's frozen. Okay, unfrozen. Okay. Okay, so this is so cool. Maybe during the closure I have some time to research it, or maybe one of you guys could research it if you're curious and then post a video for us. Okay, this is the volume of a parallelepiped, which is like the coolest word. Okay, parallelepiped. Let me tell you what a parallelepiped is. Usually I show this in class. So imagine you have a box, just a regular, ordinary box. Okay, so you have a box like with the cans, in our classrooms. Okay, and then all of a sudden, what you do is you make it like how when you take a rectangle and then you could collapse it into a parallelogram? So it's like you're doing that in 3D. It's like you're making your box like fall down and be crooked. So, like I can't draw it because like nothing's a right angle. So it's kind of hard because mine's going to still kind of look like that. But basically you have to imagine a collapsed box. Okay, so if you had a collapsed box, okay, a collapsed box, this is a box. Okay, this is called a rectangular prism. If you wanted a name, we call it a box, but it's called a rectangular prism. This one is the parallelepiped. And there's some fun pictures in the book that you'll be able to see and look at when you're doing the homework. Okay, now the volume of a parallelepiped is what's called the triple scalar product. And it's funny because I just realized why they call it the triple scalar product, which is funny because I've never realized it before as I'm trying to explain it to you. But the triple scalar product is U dot and then a cross product. So I always wondered, like, why are they calling it a triple scalar product? Triple, because there's 3 letters, right? Why the word scalar? Scalar is kind of another word for dot. Kind of. A dot product and a scalar product are the same. Anybody remember from one of the previous videos? If I do a dot product, okay, so if I do a dot product, what do I do when I do a dot product? I find it, but what do I get at the end compared to if I did a cross product? So if I do a dot product, this is just reminders. If I do a dot product, I get a number. And what's a number called in vector world? In vector world, a number
scalar.
is called a
Scalar.
Yeah, good. Okay, so a vector is called a scalar. So when I look at this, I think, why do they call it a scalar product? Because it's not 3 dot products. So to me, scalar means dot product. But what's the answer to this problem? Let me highlight it. What's the answer to a cross product?
A vector.
Vector.
A vector, nice. Okay, I love this. I love this unmicrophoning thing. Okay, so this is a vector. And then if you have U dotted with a vector, what are you going to get?
A vector.
Now, that's if it
A
was a
vector.
Vector.
Okay, hey, we need synchronous agreement. Cross product gives you a vector. What's a dot product give you?
Number. A
A
scalar.
number, or the other name for number is called a scalar. Perfect. So then you're going to get a scalar. So maybe they mean scalar product because the answer in the end is a scalar. Okay, this was also proven, but they took those book problems out. So when we change books, we don't reassign them. So it is very interesting if you wanted to prove this, because it's really cool that it comes out this way. But this turns out to be the U, the X component of the U. Let's see how I could write this. Let me write it the other way. So I'll call it U sub X. Okay, so the vectors X, this vector U vectors Y, and this U vectors Z. And then, oh, you know what they call, I'll just call it what they call it in the book. Okay, I don't like to call it this because it's with points, but I think it'll make more sense than what I was about to call it. You're going to call it U1, U2, U3. Okay, V1, V2, V3, and W1, W2, W3. And I have proven this before because I used to be proven in my class all the time, and it was so cool. Like, if you just do the cross product, it's really ugly, but if you did the cross product of V and W, like with the U1, U2, U3, if you did it with IJK, and then you dot producted it with U1, U2, U3, you end up getting the same answer as if you just did a determinant in the first place. Okay, so the triple scalar product does not represent the area of a triangle because it kind of reminds you of the except without the 1/2, the formula for the area in 2D. Okay, so this is a determinant. That means it can be positive or negative. Okay. Okay, so that's the triple scalar product. So you could think of this as a formula. Okay, so you could think of this as a formula. This never used to be on our test. We just had you do it for on homework for exposure. Not something that we do at HL, but perhaps something that you would need, and you look and it says this, and it's like, oh, well, that's a fun formula to use. Okay, so this is where it comes into place. The volume of a parallelepiped is the triple scalar product. I've never proven this before. Do you think there's a half in front of it?
No.
No.
No, how come? I agree. How come no half?
It's not
It's
a
not a
triangle.
triangle.
Okay, you guys are awesome. So it's not. Now, the answer to this could be positive or negative. So what do I also need? I'm going to change colors to write it.
Absolute value.
Absolute value. Oh, you guys are such thinkers. It's so exciting. That's the whole point of our math analysis honors class, you guys, is to teach you how to think. This is so exciting. Okay. Okay, so you do this, and what's this mean? This means determinant, right? Above. Okay, so that means determinant, but this one actually means absolute value. Okay. Or modulus if you're in English. Okay. So that's it. Now, what are you V and W? Are they points? They're not points, they're vectors. So what it is if you drew, and I'll just draw it with kind of a box. Because it would work for a box too. It works if they're perpendicular. It's just they don't have to be perpendicular. Okay, so okay, I used to be able to draw like pretty good boxes here. Okay, so here, let's draw a box like that. There we go. Okay, there's a box. So where would your vectors U, V, and W be based on the triangle? Remember when you had the triangle, you know how you had to do U and V here? So what do I have extra in mine? So here's U and V. What do you feel like would be, oh, maybe this would be better. Let me have a different U and V. Oh, let me have this one. Okay, let me have this U and V. Let's say I started from here. So what if this was U and this was V? Where would W be?
The height.
The height.
The height, right? And it's a vector, but the vector coming from, say, vector A. And then let's put does not need to be perpendicular. That's the formula I want to know. I want to know, why is the volume of a parallelepiped this thing, this object? I'm sure it has to do with like sines and cosines, because cross product is a sine times the magnitudes of the vectors, and then the dot product is actually the cosine times the magnitude of the vector. So I'm sure it has to do with that. So on this picture, the one I just drew with the U and the V, I'm going to draw like a W over here so we can kind of see it in 3D. Okay, so you have these three vectors and then they make it. This was something we never tested, but it's kind of fun. Okay, so they give you points. I wish you guys could see this picture. Oh, you can see the picture. You ready? I have my tablet. I have my camera. That's me. I don't want me. Flip it. Okay. Look at these problems. Right? Okay, let me take a picture of that so you don't get dizzy. Oh, I think I'm up and down. So here we go. Okay, so let me go to my photo. Here we go. I guess I could write vertically. Okay, so look at these pictures. See how cool these pictures look? And they say find the volume. Find the volume of the parallelepiped. Okay, so here, let's take a picture of this one. I'm going to take a picture on my phone of this. Okay, there we go. Okay, so or on my tablet. So here's the beginning, and then here's U, right? And then here's V, and then here's W. So this is a very cool question, like how does all this fit together? So how am I going to find vector U? So vector U, how am I going to find vector U? How am I going to find vector V? And then how am I going to find vector W? Now, where is that point? Can you see where that, let me make it darker. Because to me, I feel like the green dot, they didn't give me. They forgot to give me the point of the green dot. Can anyone twist this around in your brain and see where the green dot is? Do they give you a hint in the book? They do not. Can anyone figure out where the green dot is?
3.
1. 2.
Okay. Let me give you a hint. The axes are dashed. So look at the y-axis, which they only drew half of.
3.
Look
2.
at the x-axis.
2.
Look at the x-axis. Look at the y-axis. Where do the x and the y-axis and the z-axis intersect in this picture? At the green dot. The green dot is supposed to be on the x, y, and z axis. How can you be on the x, y, and the z axis all at the same time?
Zero.
0.
Yes?
0.
Yes. Okay, so that's so confusing. Okay, so this is 0, 0, 0. We did it in red so you could see it. So this is the 0, 0, 0 point. Okay, so now I could find U, V, and W, right? So U would be from the origin to U, which would be 0, 2, 2. Well, this is kind of boring. The point is the vector, which is really kind of actually cool because in equations of planes, which is what we're going to do the next time, this is called a position vector. And that's actually something that we find. Okay, and then how do you find the volume of this? Okay, you have to use the triple scalar product, but the triple scalar product just says that you put the coordinates of the vector, not the points, which coincidentally in this case is the points. But you do, no wonder people would miss it on my test. Probably because these stupid problems, if you accidentally did the points, you get the same answer. That's just because they put the point at the origin. That's so sad. Okay, and then you also afterwards, you have to do the absolute value. Right? Because the determinant can be positive and negative, but then I want a positive at the end. Okay, so I don't really even think that I can rate here for the rest. So I guess I can with all those zeros. Isn't that volume going to come out to be 0? I guess I want to do this because now I'm curious. Okay, I'm going to write this down and go back to my note sheet. And then this is actually our last example. Okay, so this is what? 0, 0. Aren't there so many zeros? I feel like I'm not going to get a volume out here, but this volume is definitely, these points are not on the same plane. I mean, this is definitely a volume. Okay, so I'm going to save that one. I'm going to go back to my note. Let's see, back to OneNote. There we go. So this is, we'll put hint. What did we just say on problem 59? The intersection, or we'll say UV. What did we figure out? UV and W start from origin. right? And then that's how we figured out U was 0, 2, 2. We figured out V was 0, 0, -2, because I also want this as a PDF if possible. And W is 3, 0, 2. Okay, and then you guys already wrote that. 0, 2, 2, 0, 0, -2, 3, 0, 2. Now there's two ways you can do this, right? So remember that video where I was saying, well, it's easier to do the columns. Remember I told you the video, it's easier to do the columns, and then I missed it, which was really funny. And then I fixed it with the other way. So there's two different ways. You can do down, 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 minus up, up, up. This is what I usually do with the, if they're all numbers, and if they're IJs in case I do it the other way. So that's 0 minus 12 plus 0 minus up, up, up would be 0, 0, 0. I love you, 0. Okay, -12. So -12 is the determinant. But what's the volume? Anybody? What's the volume? Oh, Max, I see your 0, 0, 0. Okay. What's the volume if the determinant is 12? Is the volume? I mean, well, I kind of just said it. I meant -12. So the volume is 12. Which is just unbelievable. I really want to see this. If you guys find a video, make sure you also email it to me so I could see. I'm just fascinated. Like all you do is determine it and absolute value it, and that's it. It's just fascinating. I'm so curious. I think it has to do with sine and cosine. And our like 1/2 AB sine C thing, you know, our area of a triangle in 2D. Well, area of a parallelogram. So it would just be, instead of 1/2 AB sine C, if you want a parallelogram, you could do length of this, length of this. So if you wanted to make a parallelogram, our 1/2 AB sine C or sine theta turns out to be 2 of them, right? For a parallelogram. So that's it must be where it comes from. And then you're doing that again for another one. Anyway, I am curious to see, so if any of you find the video, I'd be totally happy to find it. Okay. But that's it. So I think these are kind of fun. They're like different. Instead of you learning stuff that you're like, oh, I did that in algebra 2. Oh, I did that in algebra 2. Oh, I did that in algebra 2. It's like, no, you didn't do any of this in algebra 2. It's like new and interesting. Okay. And no pressure of a test. You're just doing the homework to learn it. So don't be copying from Slater. There's no point to that. Okay. So make sure you're doing it. Okay. So I'm going to stop my YouTube video, but I'm not going to stop my chat. Okay. So I'm going to stop the recording. Stop recording.